Hello and good morning everyone. Thank you for joining our VMware webinar today. So we're joined here by Simon Dobbs from Bytes, who will be going through the webinar with you.
Okay, morning everyone. So Simon Dobbs here. I'm a pre-sales consultant here at Bytes. I'm just going to spend a bit of time today discussing hyper-convergence in the data center and some of the drivers behind this. And so then I'll introduce VMware's key solution in this market, VSAN, and discuss why we see it such a good fit for many of our clients. So to kick off, I'm sure you're already familiar with the term, but hyperconvergence tightly integrates compute, storage, networking, and virtualization resources into a commodity hardware box supported by a single vendor. The clever stuff in a hyperconverged environment is done by the software that manages your pool of resources, which allows you to use commodity tin as the management is all done at the software layer. And in this space, vSAN is now leading the way. Although it wasn't the first to market, vSAN has seen a dramatic uptake in the past 18 months or so. In a rapidly growing area of the market, vSAN is going from strength to strength and is now leading the way. Why has it seen such a rapid uptake? Well, compared to some of the other solutions out there, it doesn't have to come bundled with the hardware layer. Although the hardware needs to be supported, it can run on a huge variety of vendors and compute and disk configurations. This provides you with plenty of flexibility and options when choosing your vSAN ready nodes. And then on top of this, its tight integration with the VMware suite allows you to build on your existing VMware knowledge and continue to use the management tools that you're so familiar with. And this rapid uptake backs up why VMware see vSAN as such a key part of their software-defined data center strategy. And by adding additional capabilities like NSX for network virtualization and advanced management tools with vRealize, this becomes a complete software-defined data center solution. Having an entirely virtualized stack and embracing SDDC can help you to move workloads seamlessly between private and public cloud solutions. Management tools like vRealize Ops can then give you an insight into how your entire stack is performing. The software-defined data center will drastically reduce the time to deliver new workloads, boost security, whilst reducing the time spent managing your environment. What are customers sort of looking to power with their hyperconverged solutions in vSAN? Well, in the real world, vSAN provides enterprise-class scale and performance, as well as new capabilities that broaden the applicability of the now proven vSAN technology to a wide variety of use cases to businesses of all types and sizes. VMware and ourselves, we've heard of many different use cases, but the most common ones tend to be business-critical apps, end-user computing, so for VDI, disaster recovery, and it's also a really good fit for your remote branch offices. As vSAN continues to get deployed for all types of VMs and workloads, we're seeing customer and market adoption grow as well. So that was a sort of brief introduction into the hyperconverged market. Where does this need come from, and what does vSAN actually look like? Well, if we think about a sort of traditional environment, a traditional employment, the deployment of separate compute and SAN technologies has often meant that you'd have high capex costs in procuring enterprise-ready arrays, and in the sort of traditional SaaS Saturdays, performance issues associated with those traditional disks has often meant that deploying an enterprise array is complex, costly to scale out, and often costly to upgrade to address those performance and capacity issues. A traditional array is generally pretty complex to manage, and it can be time-consuming to provision new storage and make this available to your virtual environment. This slow time to deploy and ultimately slows your time to market for your new apps and services. So to move away from this traditional and complex setup, we feel, as does VMware, that vSphere is perfectly positioned for this. It abstracts physical resources and can provide them as a shared pooled resource to the administrator. And because it sits directly in this I/O path, the hypervisor can make optimal decisions around matching the demands of virtualized apps with the supply of the underlying physical infrastructure. It also gives you the ability to sign service level agreements to workloads, which will reduce the operational complexity and as such significantly reduces the chances of making mistakes. So what's the goal with vSAN? Well, to reiterate, traditionally storage has been a pain point in many IT environments. It's expensive to procure, ties you not only to the hardware but also the software services of a specific vendor. The hardware dependency results in very slow adoption of emerging technologies, and the result is high costs while using obsolete technology. Traditional arrays tend to be expensive to operate and often require storage admins who are vendor-specific specialists. So the goal of vSAN and the software-defined data center in general is to change the way storage and physical resources are consumed and managed. The key goal really is to drastically simplify data center operations. By combining compute, network and storage rather than having to use 3 completely different sets of products and management tools. And because the clever stuff is being done by the software, you can leverage this clever software rather than expensive hardware, and we can take advantage of the latest and greatest, enabling you to deliver high-performance scale-out architecture. Because it's scale-out architecture, you can make gradual investments using commodity components across infrastructure, which should lead to lower costs. So what exactly does vSAN do? It allows us to pull together local storage from each of your hosts in a cluster to create a shared storage pool for the environment. It's optimized for flash even, and easy to scale out as you grow your virtual environment. Every time you add a host, you're adding storage. The management of the storage is taken away from the hardware level and is performed by the virtual layer, making it easier to manage and understand what's happening. Working with most of the major hardware vendors, VMware has lots of vSAN-ready configurations for all the major players, allowing you to build your hyper-converged solution quickly and with a supported configuration. So vSAN makes it quick and simple to provision new storage and therefore deploy new workloads, which is the end goal for all of this stuff. It's also constantly monitoring performance or make decisions to balance the workload to avoid bottlenecks. Because the storage is now managed by software, storage performance and limits can be applied on a per VM basis, allowing you to ensure that every VM gets the performance it needs to deliver your app and services. And how do you configure it and deploy it in your vSphere environment? Well, it really is pretty simple and easy. You hit a tick box and away you go. The reality is it is a little bit more complicated than that, but there are very few steps to get your vSAN ready cluster up and running. So once deployed, there's lots of great features to get your SDDC running smoothly with the performance you need. Some of the key ones being VMware's storage policy-based management allows you to define storage requirements on a per VM basis based on the needs of the applications running in your VMs. This enables you to simply define the amount of capacity, performance and availability for each VM. vSAN then matches those defined requirements to the underlying storage infrastructure. So unlike a traditional external array where provisioning is done at the storage layer, vSAN puts the application in charge and allows you to provision and control storage in an application-centric way. This greatly simplifies storage management, and as you can probably see, it will hopefully save you time and money as well. What kind of hardware can it actually use? vSAN can enable both all-flash and hybrid flash architectures. Irrespective of the architecture, there is a flash-based caching tier which can be configured out of flash devices like SSDs, PCIe cards, NVMe, etc., etc. The flash caching tier acts as the read cache, write buffer, which helps to dramatically improve the performance of storage operations. In an all-flash architecture, the flash-based caching tier is intelligently used as a write buffer only, while another set of SSDs perform the persistence tier to store data. Since this architecture utilizes only flash devices, it delivers extremely high IOPS of up to about 90K per host, and with predictable low latencies as well. Reads will primarily come from the capacity tier, although if data was freshly written, it's considered hot and not destaged. It may be read from the write cache tier itself. In the hybrid architecture, server-attached magnetic disks are pulled to create a distributed shared resource that persists the data. In this type of architecture, you can expect to get about 40k of IOPS per host. How big and how much can you scale out a vSAN cluster? Well, beyond the big numbers on this page, vSAN pretty much scales to the needs of your environment. Powerful storage tiers running on heterogeneous server hardware, but because of these big numbers, 64 nodes in a cluster, up to 7 million IOPS, nearly 6,500 VMs, it really can scale to pretty much the need of most customers. So vSAN really is now high performance, scalable and resilient, and can run on your chosen tin as well. Every vendor, every storage vendor, every sort of solution out there will have a claim to lower total cost of ownership in CapEx and OpEx, and vSAN is no different. But because you can run it on your chosen tin, you know, hopefully you can sort of make the decisions you need to get your storage capacity and performance delivered on, or maybe even under your budget. What's new in vSAN 6.2? So 6.2 was released roughly March this year, so it's been around for a few months now, but there's several new features that have been released in it. I'll just run through some of those to give you an idea of what the latest and greatest is. There's been some pretty rapid innovation around vSAN. It was 6.2 is the 4th edition, after introducing the first version only a couple of years ago. With each update, they've delivered key new features, really positioning vSAN to handle any VM workload. In 6.1, they introduced key availability features like stretch cluster for 0-minute RPO and near continuous protection. And for non-stretch cluster environments, it helps to lower the recovery RPO with vSphere replication on vSAN to only 5 minutes. In addition, key management features were added, including the integrated health service solution with new monitoring capabilities. With 6.2, it represents another major advance. In this release, they've added a suite of space efficiency features, which includes sort of, you know, true enterprise stuff like dedupe, compression, and erasure coding. In addition, there's a new quality of service controls to help guarantee SLAs, which really brings vSAN up to level to compete with sort of, you know, standalone traditional enterprise-ready storage arrays. So vSAN 6.2 can give you the sort of the claims they've got is that it can give you 7 times storage reduction with dedupe and compression. You know, with all these things, of course, your mileage will vary, but with the right kind of workloads, you will see significant savings with dedupe and compression enabled. Again, you know, this is enterprise functionality that can be delivered on your hosts, helping you to drive simplicity and reduce complexity in your environment. A couple of the new things that they've introduced are sort of new fault tolerance, RAID over the network. So how does vSAN protect your data and implement this RAID solution? It's a new sort of storage policy-based management rule, which they called fault tolerance method, which means you can choose which method of fault tolerance to use. There's a couple of different options, one of which being RAID 5 and one of which being RAID 6 over the network, again, which is also referred to as erasure coding. In this RAID 5 requires 4 hosts at a minimum, as it uses a 3+1 logic. With 4 hosts, 1 can fail out with data loss. This results in a significant reduction of required disk capacity. Normally in a traditional RAID solution, a 20 gig disk would require 40 gig of actual disk capacity. But in the case of RAID 5 over the network, the requirement is only 27 gig. And then the next option for even higher availability if desired is RAID 6 over the network, or FTT equals 2 as they also call it, which can tolerate 2 host failures. So in a traditional RAID 6 scenario for a 20 gig disk, you'd be looking at actual disk capacity of about 60 gig. But with RAID 6 over the network, this is just 30 gig. Note on the slide, the parity is distributed across all hosts, and there is no dedicated parity host or anything like that. In this case, a 4+2 configuration is used, which means that 6 hosts is the minimum to be able to use this kind of configuration. Again, this is another sort of slide that you'll see from most storage vendors, or you would do if it was showing up on your screen. You always got to have some issues in a webinar. The slide has gone, but I'll describe the slide. It's one of those slides where they claim that they can get you $1 per gig for cost of actual usable storage. Yeah, again, most storage vendors will claim to have this kind of deliver this kind of performance for that and capacity for that kind of cost. But I mean, the key point is that with dedupe and compression and erasure coding, you can see huge storage efficiency, but without the trade-offs that you would see in a traditional array. You know, thanks to sort of flash performance and hybrid as well, you can utilize those kinds of tools to really get a huge actual usable capacity out of your array. Now, hopefully, if we change slides, we'll be back to normal. Not quite. Okay, so a couple of slides missing, yeah, okay, so we will go. There's in 6.2 there's a new auto configuration, deployment and maintenance. There are a number of options that really help you to simplify your deployment and maintenance with things like VSAN templates, and it can automatically check that all hardware is compatible against the list and look for driver and firmware updates and all that sort of stuff to make it easy to manage your storage. There's also a new health service. The health service sort of helps you to manage your storage within vSphere and see exactly what's going on. And because it's tied into vSphere, it can tell you this on a per VM basis rather than on a volume level. Combine this with the vRealize suite, and you can always know exactly what's going on a per VM basis, which is not something that's really been possible with a traditional storage array. Hopefully, we're back on track now. So there's also QoS as well, and again, this can be done on a per VM level and can be enabled with just one click. Again, you know, there's probably a few more than that in reality, but it you know, it can be implemented very easily and incredibly quickly, and on a per VM level, allowing you to be incredibly granular with your performance and your SLAs. And VMware really are now seeing it as a truly enterprise apps like SAP and Oracle running in vSAN clusters. There's lots of reference architecture papers out there to help you build out these kind of environments, to deliver these kind of enterprise apps. How's it deployed and what are some of the options? Well, in a vSAN stretch cluster, you're now able to split vSAN across 2 sites. So that if a site fails, you'll be able to seamlessly fail over to the other site without any loss of data. vSAN in a stretched storage deployment will accomplish this by synchronously mirroring data across the 2 sites. This failover will be initiated by a witness VM that resides in a central place accessible by both sites. And in a similar sort of way, you can also leverage this sort of the same sort of technology to implement a DR plan. Again, there's a central witness that will monitor the 2 sites, and it will initiate the failover if the primary site fails to respond. This kind of solution can work in a metro distance, so it can provide you with a really highly redundant solution. Note, at the moment, the disaster recovery feature limit is around about 2,000 protected VMs rather than vSAN's 6,400 VM limit. Just in case that be an issue for anyone out there. And another new feature is for ROBO or remote office branch office deployments. VMware had a lot of people asking for 2-node vSAN support for these remote offices. This is sort of essentially another stretch cluster with 2 nodes in the remote office and a small witness VM in the central data center. The witness VM really is incredibly small. It just needs 8 gig of memory, 1 CPU, and storage of around about 1 gig. For large ROBO deployments, for example, 2,000 ROBOs, a customer could deploy a 3 to 4 node vSAN cluster in a central DC to host all of these witnesses. So the way this would work in the remote or branch office, you'd have your two hosts running in the cluster. They'd have your storage and your capacity, and the witness VM is literally just there just to make sure that to provide redundancy and, you know, initiate rebuilds if there was an issue on one of the hosts. When it comes to licensing ROBO deployments, it will work with vSAN Standard, Advanced, and there's also sort of special 25 VM ROBO packs for vSAN as well. Again, as I previously mentioned, it nicely integrates with the vRealize suite, particularly VROPS, the operations management tool, so you can build out lots of capacity trends and see exactly what's going on in your storage, and all from your sort of your VMware and vSphere management tools. Okay, so licensing tools and resources. The next slide goes into the different things that are available on the different licenses. You know, there's various different options here, hopefully to fit most kinds of situations. You know, if you are interested, it's probably just best to get in touch with us and we can discuss the different options and what you need out of the solution if you'd like to know some more. So next steps, you know, how do you want to get started and, you know, kick the tires and see what's involved in a vSAN deployment? One of the best ways to do that with pretty much anywhere VMware product are VMware's hands-on labs. Anyone can sign into them and anyone can test out whatever they'd like to try on a hands-on lab, and the vSAN one is no different. You can log in and it's a full-blown test lab, and you can try it out and see exactly how it works. There's also, you can have a free evaluation, so you can run a trial and test in your dev environments to see how it performs. And finally, if you decide that this is something that you'd like to implement in your data center, then give us a shout, and myself and my team can perform some vSAN assessments to analyze your data and make sure that we right-size your vSAN environment. Also, if because it is software, you don't necessarily, and you can build step by step. You can start pretty small with a vSAN deployment. So you can sort of, if you've got hosts today sat in your rack with no disks, you could fill it up with disks and get some instant extra capacity online, you know, nice and quickly, and perhaps run it as your management cluster on your vSAN, so you can begin to understand how it works and test it out in a nice small environment. And then, you know, as you grow and gain confidence in how vSAN works, you can then look to scale it out and put the sort of production ready cluster into play. So just to sum up, really, vSAN, it really is radically simple, and it can deliver everything for you in one converged stack. Although it's, you know, there's a little bit more to it. You know, a tick box will make one of your hosts ready to go and ready to deploy a vSAN node. Hopefully people are seeing out there that it can lower their TCO by sort of 50 to 70%, and it can drastically boost the performance of your storage by providing up to 100,000 IOPS per node on an enterprise-ready, tried and tested solution. Yeah, particularly with all flash architectures now, it really can drive incredible performance utilizing the existing hosts and compute that you have in your data center. So I may have been a little bit quick, but I always like to try and keep these things short and to the point. So thanks for your time. Do let me know if you have any questions, and feel free to follow up with your account managers if you'd like to know any more. Thanks.
Okay, brilliant. Thanks, Simon. So if you do have any questions, you can just pop those in the questions box and I'll read those out for Simon shortly.
Okay, so we've got a question from John here, just wondering how it compares to a product like GridStore, for example. Well, I think the main thing that I see the difference as here with sort of something like GridStore, it's on its own tin. So you'd sort of, you know, it's the tin comes with the solution, whereas with something like VSAN, it's software only, so it allows you to make more choices around exactly how you want the solution to look. When it comes to feature for feature, I'm not 100% on the exact feature set of GridStore, so that's something that we'll take offline, and we'll get back to you, John, and you know, confirm exactly the sort of key differences and the differences between the solution.
Okay, thanks, Simon. So I think that's all the questions we have for today. So thank you everyone for joining, and as mentioned previously, if you could fill out the feedback form at the end, that would be great. And thanks, Simon, for presenting, and thanks everyone for joining, and enjoy the rest of your day. Thank you.